channel Main Engineers. Since we are the main engineers, we provide main solutions. This is our first video. Hope you like it. This video is for educational purposes only. Let's start with our today's topic, and our today's topic is function, domain and. So here comes the table of contents. So first of all, we are going to discuss about the functions, definition and examples. Then we are going to discuss about the domain and range, definitions and example. Then we are going to discuss about the domain tutorial, and then we are going to provide the lastly the range tutorials. So here comes the function. Function is merely a machine that generates some output in correlation to a given input. So if you provide some input, the function will provide some output. So let's elaborate this definition. So here let's draw a box which is considered as machine, which will take some input and which will provide us the output. So let's denote the input as x and output as y, and the machine will multiply the 3 times of any input, given input. So let's provide the input 3, so our machine will give us output 9. Similarly, if we provide the input 6, our machine will give output 18. And the same way, our machine will provide the output of 8 input to 24. So what is the machine is doing here is the same thing the function is. That's why we say function is merely a machine that generates some output in correlation to a given input. So here we can write this function as fx is equal to 3x. So we can also write f of input is equal to output, and f of x is equal to y, because input is considered as x and output is considered as y. So f of 3 is equal to 9, f of 6 is equal to 18, and f of 8 is equal to 24. Let's give some real life example. So here comes the money. The amount of money you have is a function of the time spent to earning it. So if you spend more time, that means you are earning more money. So money is the function of time. Another, a shadow. The length of a person's shadow along the floor is a function of their height. So if the person have more height, the shadow length will be more. Similarly, driving a car. When driving a car, your location is a function of time. At a certain time, you will be at certain position, another time you will be at another position. So our location is the function of time. Similarly, circumference of a circle. A circle circumference is a function of its diameter. As we know, for longer diameter, the circumference will be different. For shorter diameter, the circumference will be different. We can also represent this an equation. So CD is equal to d pi, alternatively CR is equal to 2 pi r, as diameter is equal to twice of the radius. So also the position of the planet is function of its time. For different time, the position of the planet is different. So function definition. As we know, function is merely a machine which will provide the output for the given input. So let's define the function in mathematical way. So a function is a binary relation over two sets that associate to every element of the first set exactly one element of the second set, and both the set must be non-empty. So function is a relation in which each input has only one output. Let's give an example to clarify more about the definition. So as we see, let's consider two sets, set A and set B. For set A, the member is 3, 6 and 8. For set B, the member is 9, 18 and 24. 3 have a relation with 9, 6 have 18 and 8 has pair with 24. So as we see, Each element of the set A have only one output in the set B. So this is called a function. How we gonna denote the function? We can denote as f is to a tends to b. If we write to in equation, it will be becomes f function of a is equal to b. So we can write f a is equal to b. Also, a function assigns exactly one output to each input of a specified type. It is common to the name of function either fx or gx. We can write also ax, bx, cx, but normally you will find function written in fx or gx. So here comes another example. F3 means that we should find the value of our function when x equals to 3. Non-function definition. A non-function would be one that has two answers for one input. So for one input there will be two outputs. Let's see example. Y square is equal to 4, then y is equal to 2 or minus 2. So at the both time the output will be the same. So in those type where there is a one input and two output, so that is called non-function. If you graph this, you would have a point directly above the other point on a graph. If any vertical line intersects the graph more than once, the relation represented by the graph is not a function. Let's illustrate this line by a sketch. So here, as we see the wave, if we draw what is said, if any vertical line intersect the graph more than once, the relation represented by the graph is not a function. So if you draw a vertical line here, so you see only one point of contact. Similarly, if you draw any vertical line anywhere on this wave, you will only find one point of contact. That means it is a function. Similarly, another here, as you see this curve. So here, if we draw a vertical line, so how many point of contact? There is a 2 point of contact here and here. So at a given input, like here, if it is our input, so there will be two outputs. So if you find like this, for one input, two output, that means this is non-function. Similarly, let's take one more example. Let's draw oval. So here, if we draw a vertical line, how many point of contact we get? We get 2 point of contact. So for this given input, we will have a 2 output. So this is also a non-function. So here we are going to differentiate between relation and function. So a relation is a set of inputs and output that are related in some way. When each input in a relation has exactly one output, the relation is said to be a function. So when each input has one output, then that relation is called function. Otherwise it is not function. It is the same way. If one input have more than one output, then that is not a function. If one input have only one output, that relation is said to be function. So to determine if a relation is a function, we make sure that no input has more than one output. So remember, all functions are relation, but all relation are not function. Let's give an example. Let's say a relation 1 has it has 3 sets of pair, 1a, 5a and 8b. Let's draw in a sketch. So the first members of the pair set is a domain. So 1, 5 and 8 is domain 1, 5, 8, and the next set of pairs is range. That means our range is A and B. That means A and B. For the two inputs 1 and 5, there is only one output A, and for another 8 input there is output B. So here we can see each input have one output. That means this relation 1 is function. Similarly, let's take another example, relation 2. So here is also 3 sets of pair. So let's draw it in a sketch. So the first member of the pair set is domain. So here domain is 1, 5 and 5. That means 1 and 5. And range is B, A and C. That is A, B, C. So 1 have a relation with B. That means 1B. 5 have a relation with A. That means 5A. 5 have a relation with C. 5C. So here, as we see, one of the input has 2 output. 5 have 2 output, A and C. That means this is a relation, but it is not a function. So we can write relation 2 is not a function. Domain and range. So how are we gonna define domain? So domain is all set of possible input values, and range is all set of possible output values. We can also say domain is all first element of ordered pair. That means all x coordinates are domain, and range is all second element of the ordered pair, that is y coordinate. Domain are independent value, but range are dependent value. Let's give an example. Y is equal to fx. So here domain is equal to all values of x for which fx is defined. That means our function is going to be gives us a valid answer. And range is all values of y. That means the all values of output is range and all values of input is domain. Let's give one more example. Like let's consider 2 sets. Set x consists of a member 3, 6 and 8. Set y consists of a member 9, 18 and 24. And so these x components all are domain, and y component, that is output, is all our range. So we can write domain is equal to 3, 6 and 8, and range is equal to 9, 18 and 24. So what are the main conditions to be a function? This is going to be very important, because we are going to use this condition in all the question of the domain and range. So here comes the first condition. So first condition, denominator cannot be 0. That means if the denominator is 0, that means equation is going to be undefined, and we don't need undefined equation. We need a valid solution. That's why always remember denominator cannot be 0. Another thing, numerator should be always greater or equals to 0. Let's give an example. So here numerator is x minus 1 and denominator is 2 minus x. So as we know, denominator cannot be equals to 0. That means 2 minus x cannot be equals to 0. And numerator should be always greater or equals to 0. That means our x minus 1 is going to be either greater or equals to 0. So in this way we can find the domain of the given equation. So let's come for the another condition, second condition. So always remember, root should be non-negative. For the real solutions, the root is always going to be positive. So if the root is in denominator side, then equation should be always greater than 0. If the root is in numerator side, then equation should be always greater or equals to 0. Let's give an example to clarify this both statement. So here example, our equation is root over x minus 1 and divided by root over 2 minus x. So as we know, in the both the place numerator and denominator there is a root. So if the root is in the equation, then that means our denominator equation should be greater than 0. That means root over, that means 2 minus x equation is going to be greater than 0, and numerator equation x minus 1 is going to be greater or equals to 0. So let's come for the third condition. Third condition is a square of any number is always going to be greater or equals to 0. Why? Let's give an example. If we do any number a square, what do you get? Let's say we square for minus 10, we get 100 plus 100, and if we do a square of 0, we will get 0. If we get a square of plus 10, we will get plus 100. So the square of any number is always going to be either 0 or positive. That's why we can say a square of any number is always going to be greater or equals to 0. Let's give an example like y square is equal to root over x square minus 16. So here the y square is always going to be either 0 or greater than 0. Then we can write y square is greater or equals to 0. Find domain of the equation. So what is the equation? Fx is equal to x square. So what is going to be? So x square is going to be valid for any given number here. So we can give any of the number and our equation is going to be valid. So domain is going to be all values of x. That means x belongs to a real number. For all value, if we are going to draw a sketch, so minus infinity to infinity, and here is going to be 0. So all values from minus infinity to plus infinity, the equation is going to be valid. So our domain will be from minus infinity to infinity. Let's say in second question, here the equation is fx is equal to root over x minus 2. So we remember the condition, root is not going to be negative, and if the root is in numerator side, then the equation is going to be greater or equals to 0. So we are going to use the same condition here. So for fx to be defined, equation is going to be greater or equals to 0. That means x minus 2 is going to be greater or equals to 0. That means x is going to be greater or equals to 2. Domain is equal to, so here what is the domain? Domain is going to be equals to 2 and greater than 2. So from we can include, this means include 2 to infinity, and this bracket sign means excluded because we don't know the end point. So we cannot include the infinity as infinity is indefinite. So always whenever you are going to use infinity, use the bracket sign. That means excluded, and this sign means included. So here comes the another question. Comes the question number 3. Fx is equal to 1 divided by root over 1 minus x. So as we know, if there is a root in the question, then the root is always going to be non-negative, and if the root is in denominator side, then the equation should be greater than 0. We are using the same condition here as well. So for fx to be defined, 1 minus x is going to be greater than 0. That means x is going to be less than 1, and domain is equal to all the value less than 1. That means domain is equal to from minus infinity to 1. But see here I use the bracket sign. Why? Because there is no equals to sign here. That means x is always going to be less than 1, and it's not going to be 1. That's why we cannot include 1. That's why also in the infinity side we don't know the end point, so we cannot, here also we have to use exclude sign. So we have to use the bracket. From minus infinity to 1 will be our domain. Here comes the question 4. So what is the equation? Root over x minus 1 divided by 2 minus x. So as we know, again, root is going to be non-negative, but for fx to be defined, 2 minus x is the denominator cannot be 0. So 2 minus x cannot be 0 here, and then x is not going to be equals to 2. Also, we know the root is not going to be, root is non-negative. That's why we can say x minus 1 divided by 2 minus x is always going to be either greater or equals to 0. So whenever you see anything like this, so how are you gonna solve the equation? Always multiply by denominator. So how are you gonna solve the equation? Always multiply by denominator. So we are going to multiply by denominator, the up and down. So multiply by denominator, we will get x minus 1 into 2 minus x divided by x 2 minus x into 2 minus x greater or equals to 0. Then x minus 1 divided by 2 minus x divided by 2 minus x whole square. So this is going to be greater or equals to 0. As we know, x is not going to be 2 equals to 2. So for all other values, 2 minus x square is going to be positive. So as we know, square of any number is going to be positive. That's why this is going to be positive. So as for all the equation, whole equation is going to be either greater or equals to 0. So this term x minus 1 into 2 minus 2x is also going to be positive. That means x minus 1 into 2 minus x is going to be either greater or equals to 0. So let's draw a graph. To solve this kind of equation, always we have to draw a graph. Let's draw a graph from minus infinity to infinity, and then cut the interval at what the value of x is going to be 0. So in this equation, at x is equal to 1 and x is equal to 2, the equation is going to be 0. So we just cut the interval at 1 and 2. So our interval will be from minus infinity to 1, 1 to 2, and 2 to infinity. So let's put any value for this region from 1 to infinity. Let's take 0. So once we put 0 in the equation, so 0 minus 1 is equal to minus 1, 2 minus 0 is equal to 2. So 2 into minus 1 is greater or equals to 0 is not valid. So for this reason, our equation is not going to be valid. So take any number for this region. Let's take 1.5. So 1.5 minus 1 is equal to 0.5, and 2 minus 1.5 is equal to 0.5. So 0.5 square is going to be greater than 0. So for this reason, the equation gives a result positive. That means for this reason, our equation is going to be valid. Again, take the number, any number from this region, from 2 to infinity. Let's take 4. So 4 minus 1 is equal to 3, 2 minus 4 is equal to minus 2. So minus 2 into 3 is equal to minus 6 is not greater than or equals to 0. So for this reason also, we will get all the negative value. That means for this reason as well, the equation is not valid. So our equation valid only for this reason. So our domain is equal to 1 to 2. But as we see, we can include 1, but here I exclude 2. Why? Because x is not equals to 2. For x is equal to 2, our equation is going to be invalid. So we cannot include 2. So we have to exclude 2. So our final domain will be 1 included and 2 excluded. Here comes the question number 5. Root over 16 minus x square. As we know, anything inside the root is non-negative. So when the root is in numerator side, so either it is going to be greater or equals to 0. So we use the same condition here. So 16 minus x square is going to be greater or equals to 0. Yes. So when you solve it, it is in the a plus b, m minus b form. So it is going to be 4 minus x into 4 plus x going to be greater or equals to 0. Again, as we see previously, how we gonna solve this question? We are going to sketch a drawing. So minus infinity to infinity, and we have to cut the interval at which point? At the point where this equation is going to be equals to 0. So x is equal to 4 and x is equal to minus 4, the equation is going to be 0. So we cut this minus infinity to infinity at minus 4 and 4. Again, we are going to put the value from this region, and from 4 to infinity region. So first of all, let's put the value from minus 4 to infinity. Let's put minus 5. So 4 into minus 5 is plus 9. 4 minus 5 is equal to minus 1. So minus 9 is not going to be greater or equals to 0. That means for this reason we will get negative value, which is invalid for our equation. Let's take any value from this region. So minus 4 to 4, let's take 0. So 4 minus 0 is 4. 4 plus 0 is 4. 4 into 4 is 16, is greater than 0. That means for this reason all the solution is positive. That means equation is valid for all the numbers for this reason. Let's take another point from any of this reason from 4 to infinity. Let's take 6. So 4 minus 6 is minus 2. 4 plus 6 is 10. 10 into minus 2 is minus 20, which is not greater than 0 or 0. So for this reason as well, we get all the negative value, which is not valid for our equation. So only valid reason is from minus 4 to 4. So our domain is going to be minus 4 to 4. Both sides we include minus 4 and 4 as well, because here is the equals to sign. So this equation is either going to be greater than 0 or is equal to 0. So we have to choose both minus 4 and 4 as included. Sixth question. Again, the root over x square minus 16. For fx to be defined, again anything inside the root is going to be either 0 or greater than 0. So we can use the same. X square minus 16 is either going to be greater or equals to 0. Again, it is in a square minus b square form. So a plus b, a minus b, x minus 4x plus 4 is greater or equals to 0. Again, for this type of question we use sketch, and we just put for this reason one value, this reason one value, this reason one value. Let's take any value from minus infinity to minus 4. Let's say again minus 5. So x4 minus 5 minus 4 minus 9 minus 5 plus 4 minus 1. So minus 9 minus 1 is 9 is greater than 0. So our equation is valid for this reason. We get all the positive result for this reason. Let's take any value from this. Let's take 0. So 0 minus 4 minus 4, 0 plus 4 4. So minus 16, which is negative. So our equation is not valid for this reason. Let's take any number from this. Plus 5. So plus 5 minus 4 is 1, and 5 plus 4 9. So 9 into 1 9, which is positive. So for this reason as well, our equation is going to be valid. So what is the domain? Our domain could be from minus infinity to 4, but this is not going to be included. Again, from 4 to infinity. So our domain is equal to minus infinity to minus 4 union 4 to infinity. As you see here, I use the brackets in, that means not included as we don't know the end point, but here minus 4 is included as the equation is equals to 0 as well. Union 4 is included because equals to 0, and again infinity is excluded as we don't know the end point. So in this way we can solve this type of question. Let's take one more question. So 1 by root over x square minus 16. Again, anything on the root should be non-negative, and it is in denominator, so it is going to be greater than 0. So we use the same condition for x to be defined. X square minus 16 is going to be greater than 0. So a square minus b square form. Again, x minus 4, x plus 4. Again, we have to sketch the drawing to find out the solution, to find out the domain. So here Again, our equation is going to be 0 at x is equal to 4 and minus 4. So we draw minus infinity to infinity, and we got the interval minus 4 to 4. Again, we are going to put this region value. So let's go to minus 5. So minus 5 minus 4 minus 9 and minus 1. So plus 9. That's the value for this region. The equation is valid for this region. For this region, let's take from minus 4 to 4. Let's take 0. So 0 minus 4 0 plus 4 4, so minus 16. So the equation is in negative, so this is not, so answer is not valid for our equation. So we cannot take this region value. So again, let's take value from 4 to infinity. Let's take 5. So 5 minus 4 1, 5 plus 4 9. So it is going to be 9 into 1 9 is greater than 0. That means our equation is valid for this region as well. So what is the domain? Our domain is going to be from minus infinity to minus 4, but we cannot include minus 4 because there is no equals to 0 sign. The equation is not equals to 0, so we cannot include minus 4. So minus 4 is excluded, union again from 4 to infinity, but we cannot include 4 because equation is not equals to 0. So 4 to infinity. So these signs are bracket, included, excluded signs are very important. You should be very careful while you are putting those type of signs. So that's it for the domain. Here we gonna find the range of a function y is equal to fx. So the first step to find the range is always put y is equal to fx. So whatever your function, just put y is equal to your function. The second step is express x as function of y. So whatever your function, just express the function in terms of x as y, function of y. The third step is find the possible values for y. Just like domain, in the domain we find the possible values of x, the input possible values, and here we are going to find the output possible values. The steps and the conditions is going to be same. Just ask yourself that is y is always positive or always negative or maybe not equal to certain values. So these are the things you have to consider while you are writing the final equation for the range. The fourth step, eliminate the values by looking at the definition of the initial function, especially used for the square root function. So the last step is only used for the square root function. So for all other equation, the first three steps is enough to determine the range. So always remember, draw a sketch. In math, it's very true that a picture is worth 1,000 words. So always draw the graph, draw the sketch, so it will be better to find out the possible solution. So the first question, find the range of the equation. First question is fx is equal to x minus 3 divided by 4 minus x. So the first step is put the y is equal to fx. So we are going to put y is equal to x minus 3 by 4 minus x. Step 2 is express x as function of y. So what we are going to do, just do the cross multiplication. So x minus 3 is equal to 4y minus 4y minus xy, and then x plus 4y is equal to 4y plus 3. Just take common x. So x is equal to x into 1 plus y is equal to 4y plus 3. X is equal to 4y plus 3 divided by 1 plus y. So our range is going to be, we know the condition, the denominator is not going to be equals to 0. So here y cannot be equals to minus 1. For all other values, this function is going to be gives valid answer. So our range is y belongs to real number, only 1 minus 1 is going to be excluded. So the final range is y belongs to real number minus 1. Let's go to the another question. Fx is equal to 1 by root over x minus 3. So the first step is write y is equal to fx. So just write y is equal to given function 1 by x root over x minus 3. The second thing, again, if the root is in denominator side, so how we gonna remove the root? Just square both sides. So y square is equal to 1 divided by x minus 3. Just do the cross multiplication. 1 is equal to xy square minus 3y square, and x is equal to 1 plus 3y square by y square. So here, so this is the final equation, but our range is going to be y is equal to real number, but only what is the missing number? This equation is going to be always positive or 0, but we cannot take 0 because in the denominator cannot be 0. That's why our range is going to be y belongs to real number, only 0 is going to be excluded. For all other values, this equation is going to be valid. Let's go to the another question. Fx is equal to root over 16 minus x square. So first step, y is equal to fx, so 16 minus x square. So how we gonna remove the root? Just square both sides. So y square is equal to 16 minus x square. So x square is equal to 16 minus y square. So here, as we know, as we mentioned earlier, so here x square is going to be greater or equals to 0 because square of any number is not going to be negative. It always is going to be either 0 or positive number. So as x square is going to be greater than 0, that means this part is also going to be greater than 0. So once we solve the equation, it is in a square minus b square form. So again, 4 minus y into 4 plus y is greater or equals to 0. Then here comes the question number 3. Fx is equal to root over 16 minus x square. So the first step is always y is equal to fx. So y is equal to root over 16 minus x square. So how are we gonna remove this root? So square both sides. Y square is going to be is equal to 16 minus x square. So when we express y as a function of x, so x square is going to be 16 minus y square, and here, as we know, a square of any number is going to be non-negative. That means x square is going to be either 0 or greater than 0. So we can write x square greater or equals to 0. That means this side is also going to be greater or equals to 0. So 16 minus x square is also going to be greater or equals to 0. So it is in a square minus b square form. Solve it. So we get 4 minus y into 4 plus y greater or equals to 0. So how are we gonna solve this type of equation? Draw a graph, and from minus infinity to infinity, make an interval at the point where this equation is going to be 0. So what point is going to be 0? 4 and minus 4. So we'll draw a graph minus infinity to infinity, take interval for at minus 4 and at 4. So put any value from minus 4 to minus infinity. Let's put minus 5. So minus 5, 4 into minus 5 is plus 5. So plus 4 plus 9, 9. 4 plus 5, 9 into 4 minus 5 minus 1. So 9 into minus 1 minus 9. So all the number for this interval is going to be negative. For this interval, minus 4 to 4, let's take a 0. So 4 minus 0, 4. 4 plus 0, 4. 16 is going to be positive. For this reason, let's take 5. So 4 minus 5 is minus 1. 4 plus 5 is 9. 9 to minus 1 minus 9. So for this reason, it's going to be negative. But our equation is always going to be greater or equals to 0. That means it's going to be always positive. So our reason for from minus 4 to 4 is only valid. For other reasons are invalid for our equation. So y belongs to minus 4 to 4. Both the side it will be included because here is a equals to 0 sign. So, but as we see our initial function, as we mentioned in the step 4, that we have to look for the initial function as well. So as we see in the initial function, the root of any number is going to be non-negative. That means the output of this number is always going to be either 0 or more than 0. So we have to eliminate the number from this region. That means, let's say here is a 0, so from 0 to minus 4 is going to be removed from the value of y, as our output is not going to be always positive. So square root of the number cannot be negative, so we need to eliminate the number values from minus 4 to 0. So our range is going to be from 0 to 4, that the remaining from 0 to 4, 4 is going to be included as it is equal to 0. So let's come to the next question. Fx is equal to root over x square minus 16. So again, y is equal to x square minus 16, as we have to express y is equal to fx. Square both sides. Y square is equal to x square minus 16. Take x square is equal to y square plus 16. So x square is going to be greater or equals to 0, as the square of any number is going to be non-negative. So y square plus 16 is also going to be greater or equals to 0. That means, so y is going to be valid for any real number. But again, we have to see the initial function. It is the root. So root of any equation is going to be either 0 or positive. So we have to eliminate the value from minus infinity to 0 from the real number. So square root of the number cannot be negative, so we need to eliminate the values from minus infinity to 0. So range is equal to 0 to infinity. 0 is going to be included, as it is equal to 0. So this is our range. Thanks for watching. Hope you liked this video. For any questions, feedback or suggestion, please comment or email us at mainengineers@engineer.com. Goodbye for now, and goodbye until next time.